So in example 5 of day 5 note, or of unit 5 notes, the very last lesson that we do has something to do with this thing called CPC-TC. So we're talking about that down here in a minute. But the one thing I do want you to add in is we would also be talking about possibly HL, which is that hypotenuse leg theorem, because that does fit in with the triangle congruency, and I don't want that to be left out when you think about what are all the ways you can prove a triangle to be triangles to be congruent to each other. So first and foremost, this one is going to be a flow proof. Example 1, I went ahead and gave you all the statements. We got to come up with all the reasons. Okay, so whenever the flow proof starts out, okay, each one of these rows, it's something that's given to you. So like segment BE bisects segment AD at C. So BE bisects AD at C. Okay, well that's given. And if that is given, then we know that this is congruent to this, and this is congruent to this one, because C is the midpoint of each one of those. Okay, it bisects it, it's the middle. Alright, now, if that's the case, we just said AC is congruent to DC. Okay, and that was because the definition of bisector. Okay, then we have that segment AB is perpendicular to BC and that DE is perpendicular to EC. So that's given to us in the picture. We have those right angles given to us. It says then angle ABC and angle DEC are right angles. Okay, yeah, that's what that happens. So when we're given the definition of perpendicular lines, then we know that the angles become right angles. So that was because of definition of perpendicular lines. Alright, now moving on, we also know then that triangle ABC and triangle DEC are right triangles. Absolutely, we have that one right angle. They're right angles, or they're right triangles because they have right angles. So that would be a definition of right triangles. Alright, then we go on to say segment AB right here is congruent to DE. So AB is congruent to DE, and that's given to us. Okay, I think I jumped the gun a little bit. Let's just put 3 marks here because that's kind of confusing. And let's take away this for right now. Okay, so AB is congruent to DE, right here and right here. So that's given. Alright, so now, once we know all these different things, we know that we've got this right angle. We have AC is congruent to DC. AC is congruent to DC. We have AB is congruent to DE. We now can say, hey, these two triangles are congruent to each other. How are they congruent to each other? Well, we have a right angle. AB and DE are considered legs of a right triangle, and the AC and the DC are considered the hypotenuse of each one of those triangles. So we've just proven HL theorem. Alrighty, now moving on to the CPC-TC. This means that corresponding parts of congruent triangles are congruent. So let's fill in everything that we know. We know that our sides are congruent. Like AB is congruent to DE. And I just use the congruency statement right here. So AB is congruent to DE. BC is congruent to EF. And then lastly, CA is congruent to FD. Okay, those are our sides. Now we look at our angles. So angle A would be congruent to angle D. Angle B congruent to angle E. And then lastly, angle C is congruent to angle F. Okay, so you only can use when asked to prove parts are congruent of a triangle, but first you must prove the triangles are congruent. So I'm going to jot this down because I just think it's important for you to reread it a couple times. So first, you use this when you're asked to prove parts. When you say parts of a triangle, like their angles and their measure, like their side lengths and their angle measures, are congruent. But first, you must prove the triangles are congruent. And that's by using like SAS or ASA, HL, side, 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 one of those types of things that we've been practicing in day 4, and then we're going to be practicing again here today as well. So looking at example 2, we are given that angle KBC is congruent to angle ACB. Angle KBC, so this right here, and angle ACB, so this right here. So these two are congruent. That's given to us. All right, then we also can say that BC is congruent to itself, and that's just the reflexive property. Of equality. Okay, then we were also given that angle K is congruent to angle A. So we have just proven, like if you look at this, you have an angle, a side, and an angle, right? So this angle, an angle, and a side. Angle, angle, side. So we've just proven that the two triangles are congruent by angle, angle, side theorem. Does that mean that KB is congruent to AC? Well, absolutely. If we've proved the triangles are congruent by one of those congruency theorems, then by the CPCTC, all of the sides are congruent. All the sides that you correspond to each other in the triangles are congruent. All the angles are congruent to each other in each triangle. So we can prove CPCTC because we proved that the triangles were congruent by one of those triangle congruency theorems. Okay?